In this lecture, I'll be discussing about minimum spanning tree. Before understanding a minimum spanning tree, we should know what is a spanning tree. So a spanning tree, you can consider an undirected and a connected graph. Undirected means there is no arrow between any vertex in a graph. So here in this graph, which is in orange color, we have four vertices V1, V2, V3, V4. We have lines connecting the vertices. So the lines connecting the vertices are called as the edges. So a graph is a combination of vertices and edges. So in a spanning tree, let us consider an undirected and a connected graph G, combination of vertices and edges. A spanning tree of the graph G is a tree that spans G, which is it includes every vertex of G and is a subgraph of G. So subgraph is something like a subset. Every edge in the tree belongs to G. So here, given this undirected graph, I have to include all the vertices in my spanning tree. It's not necessary that I use all the edges to connect this vertices. So here, this is one spanning tree where I have all the four vertices. It is all connected using just three edges. Consider the second spanning tree. Here I have again four vertices in my graph. This is one graph. So we have four vertices in this graph connected by three edges. And this is another spanning tree where I have all the four edges connected by three edges. Similarly, here this is another spanning tree. Here I have four vertices connected by three edges. So for this one undirected graph, we can have any number of spanning trees. Now coming to the minimum spanning tree. The cost of the spanning tree is the sum of the weights of all the edges in the tree. There can be many spanning trees. Minimum spanning tree is the spanning tree where the cost is minimum among all the spanning trees. Again, if the minimum tree cost is with more than one graph, then we can have many minimum spanning trees. So now consider this is the given undirected graph. We have four vertices here and five edges. So 1, 2, 3, 4, 5. 5 edges. Every edge is having a cost. Now we are going to build a spanning tree such that the cost is minimum. So here in this orange color, so you can see that we have all the four vertices because minimum spanning tree means we have to consider all the vertices and it should be connected with minimum cost edges. Consider one possibility, 4, 5 and 2. So in total, so we don't include this and this. These two edges we are ignoring. If that is the case, my minimum, this spanning tree's cost is 4 plus 5 plus 2, which is 11. Consider another possibility, ignoring this edge and this edge. So I have to include all the four vertices. 4 plus 1 plus 2, which is equal to 7. So when I consider this and this is the minimum cost spanning tree. So we have to check all the possibilities and find out which is the minimum spanning tree, which is of low cost. So connect all the vertices with minimum cost edges. That is the minimum spanning tree. There are several applications when it comes to minimum spanning tree. Designing networks, the famous traveling salesman problem, so finding a solution for that. The other real-time applications can be cluster analysis, handwriting recognition, image segmentation, and so on. The most popular algorithms for constructing minimum spanning tree is Prim's algorithm and Kruskal's algorithm.